Welcome again. We're going to continue now with the NC positioning system. Last time when we talked about the motion control in the CNC machine, we highlight that we can control the motion of the CNC machine by using servo drive and also servo motor, all connected to the controller. And we said the controller will give the command to the servo drive, and the servo drive will convert this command into a signal that will be understood by the motor to rotate and change the position of the for example the machine head or the machine spindle. Then there will be encoder to measure the actual position and give and also the velocity and give it as a feedback to the controller. So at that time when we talk about the servo the motion control of the CNC machine, we didn't go in the type of the motion or the positioning system control, which was one of the criteria that we classify the CNC machine according to the loop control. When we said we have some CNC machine with the open loop control and other CNC machine with closed loop control. So in this video we are going to talk about this type of loop control, which is open loop and closed loop. But before we go for that, we need to know that usually the typical motor here, along with the lead screw, they are used like one arrangement or like interconnected system in order to move the work part or the work table here uh, along the axis of motion. So if we have axis of motion, so this is the rotation will be, for example, for the lead screw, and this rotation also will result in the movement of the work table here, either for this side, for example, or to that side. Depends. That means the lead screw here is responsible to convert the rotational movement into linear movement. So the rotational movement that will be generated by the servo motor or stepper motor here will be converted into axial movement along this axis, either, for example, away to the machine, or close to the machine, away from the part, close to the part, away from the spindle, close to the spindle, and so on. Okay, so for the XY capability here, the apparatus would be piggybacked on the top of the second perpendicular axis. So if you have, this is X axis here, for example, or Z axis, for example, and here we have X axis will be on this way. So it will be perpendicular to each other if we have only machine of two axes. So the numerical control positioning system here will convert the coordinates that will be received from the part program. So usually the coordinates of or the position that we are going to define, either using absolute coordinates or incremental coordinates and so on. These coordinates will be embedded or included in the part program, and the MCU unit will receive this or will convert this program or code into a position command, which will be received by the motor in order to move either the work part or the work table to the specific or the target position. Okay, so usually we have this screw. It has a batch unit here. So the batch unit, which is measured in the or P here, is measured in either in inch per thread or millimeter per thread, depends on how many page and how many thread are there. So the table moves distance equal to the page for each revolution. So we have revolution, that means revolution, which is a complete rotating cycle, which is 360 clockwise or counterclockwise based on the direction of rotation. And we have also the movement of this page from one thread to another thread, along this coaxial or axial motion. So here it's more clear about the lead screws and what are the component of lead screw and what is the pitch here. So the pitch, which is the distance between the two thread here. So you can see here this one equal with one pitch and another pitch here, also lead screw is consists from many. So each movement here, or the number of, if we want to define the batch here, is the distance between the adjacent screw threads. So we have one thread, another thread. What is the distance between these two threads? So it gives you the, we call it the batch. So the batch here, how many numbers? I mean, we are going, it will be measured either in millimeter per thread or inch per thread, so we can know how long this table will be able to move from, for example, from the point here which is close to the motor until the end point here. So this will depends on how many threads that we have on this screw, and what is the, how many pitch, and how many or what will be the distance either in inch or in millimeter. Okay, so there is also another unit, I mean this formula in order to calculate the teeth per inch here. So the number of teeth per inch, which is n, number of teeth or thread per inch is equal to n over equal to 1 over p. P is the value of the pitch or the distance between each two of these threads. So here this formula is used to calculate the number of teeth per inch. So how many number teeth you need to move for 1 inch, for example. If the number of, I mean per 1 inch, I can move for 2 teeth, 3 teeth, and so on, depends on what is the screw component here. Then we have the unit for, I mean another parameter which need to know, which we call it basic length unit. So the basic length unit is here is equal to the number of pitch in order to the number of I mean the number of pitch in to the number of the, or the speed of rotational of the machine. So this is n here is the pulse per revolution. How many pulses generated by one revolution? We said one revolution is equal to 360. So PLU here equal to P over N, which equal, for example, if we have here like an example, if we said CNC machine or NC machine use zero point 0.1 pitch lead screw, that means the distance between the two thread is equal to point 1 here, point 1 pitch lead screw and 100 pulse revolution per revolution here. So PLU is equal to P over N, which is zero point 0.1 inch per revolution. That means I mean zero point 0.1 inch per revolution. This is the value here of the P, and also the 100 here represent the value of the N. So this is N, this equal to the value of P. So it will give you, for example, 0.001. So this is just simple calculation that used to define uh, the distance that can be moved along the screw, or how the how the lead screw will convert the, I mean the rotational movement into a linear movement. There are two type of encoder hair configuration for the lead screw. One we call it pole screw, and the other is ACME screw. So the lead screw is a screw specialized for the purpose of translating rotational into linear motion, as we mentioned before. So the second, it's a good example for this lead screw is the table on the milling machines. So the X and Y axis here all move along the lead screw, because this the table here. We need to convert this rotational motion into axial motion. So for that type we use this type of lead screw.